Hi, today we're going over section 5.2, which is angles in standard position in all quadrants. We solve these in a similar manner to angles in quadrant 1. Some key things to remember when solving problems is our terminal arm or radius is always positive. So that's our hypotenuse when we create a triangle with it. Our adjacent and opposite sides can be negative. It all depends on what quadrant you're in. Our reference angle is measured off our nearest x-axis and is always positive. So in quadrant 1, our reference angle and our actual angle are the same thing. In quadrant 2, our actual angle goes from here to here, but our reference angle goes to nearest x-axis. In quadrant 3, our actual angle is from here to here, and once again, references to nearest x-axis. In quadrant 4, our actual angle is this angle here, and then our reference angle is to this axis here. Now we'll do some examples. So find the three trigonometric ratios for following points. So we'll go through 4 different points and then we'll find some patterns. So first one is 0.3, 4. So that's 3 for x, 4 for y. So we can essentially create a triangle from this. So we know that our x is 3. Our y is 4. Now, our reference angle would be here. So this would be our opposite side. This would be our adjacent side. We don't have our hypotenuse. We can use Pythagoras to get that. So we've got c squared equals a squared plus b squared. So we have c squared is equal to 3 squared plus 4 squared. We have c squared is equal to 9 plus 16. So c squared is equal to 25. Take the square root of both sides and c is equal to 5. Now we'll write out our trig ratios for sine, cos, and tan. So we have sine of our angle is our opposite over our hypotenuse. So our opposite was 4. Our hypotenuse was 5. Cos of our angle is our adjacent divided by our hypotenuse. So that would be 3 over 5. And tan of our angle is opposite over adjacent. So our opposite was 4 and our adjacent was 3. Okay, so we'll go on to next example. We have point -3, 4. So at -3, we are at 4. So once again, draw our triangle in. So our x was -3, our y was 4. I use the same values as the last one, so you don't have to recalculate our hypotenuse. And then we'll write out our trig ratio. So sine of our angle is our opposite, which in this case would be 4, over our hypotenuse of 5. Cos of our angle is our adjacent side, which is -3, divided by our hypotenuse, which is 5. And tan is our opposite, which is 4, over our adjacent, which is 3. We also have a negative there, so -4/3. Okay, so next we'll look at one in quadrant 3. So we have -3, -4. So that, for example, would be about here. We'll create the triangle, label our sides. So this is -3, -4. This is 5. So sine of our angle is still our opposite of -4 over our hypotenuse of 5. Cos of our angle is our adjacent of -3 over our hypotenuse of 5. And tan of our angle is our opposite of -4 over our adjacent of -3. Our negatives will cancel out, so that gives us positive 4 over 3. Next, we have one in quadrant 4. So the point would be approximately here. We'll draw in our triangle. So this is 3, this is -4, this would be 5. So sine of our angle is equal to our opposite, which would be -4 over a hypotenuse of 5. Cos of our angle is our adjacent of 3 over our hypotenuse of 5. And tan of our angle is our opposite of -4 over adjacent of 3. Okay, so now we'll look back at these and find some patterns. So you'll notice that in this quadrant, only one thing's positive, other two are negative. Same with this one, only one is positive, other two are negative. Same with this one, only one is positive, other two are negative. And then in our first one, everything was positive. So from this, we'll get something known as the Castro, which we'll go through shortly. But when looking at those, you'll also notice that there's two quadrants which each ratio is positive in, and two that will be negative in. So for example, sine is positive in this quadrant, as well as it was positive in this quadrant, where the other two were negative. If we go back, then cos was positive in quadrant 1, and then it was positive again in quadrant 4. Tan was positive in quadrant 1, as well as quadrant 3. So each ratio has two quadrants that will be positive in and two that will be negative in. Now this brings us to the Castro, which tells us which quadrants each trig ratio is positive or negative. So quadrant 1, which we have for A, so Castro, we spell out cast starting in quadrant 4 and going counterclockwise. So A stands for all ratios. So in quadrant 1, all ratios are positive. S stands for sine is positive, which means cos and tan are negative. T is tan is positive, which means that sine and cos would be negative. And then in this quadrant, cos is positive. Okay, so example, find the angles in standard position that have a ratio of sine is equal to 0.5 over the domain from 0 to 360. So our first step is to find the quadrants sine is positive in and draw each angle out. So I'll just draw a mini quadrant grid here. Do our Castro. From this, we can see sine is positive here and here, so that means it's not here or here. So we'll then draw two separate grids, one for each of our answers. Drawing a terminal arm in each one of them. Next, we find our reference angle. To do that, we take our sine of our angle is equal to 0.5, and we arrange it so we have our angle is equal to sine -1 of 0.5. So that gives us 30 degrees. Now this first one in quadrant 1, our angle will simply be 30 degrees. This one here, our reference angle is 30 degrees, so we have to calculate what this is. So we'll find the overall angle of this. So we know from here to here's 180. We're short by 30 degrees, so we'd have 180 minus 30. So that gives us 50 degrees. Or sorry, 150 degrees. Okay, so practice for this section starts on page 426, is numbers 3 to 7, 9, 10, and 13.